Sometimes we form an opinion about something, and then we get information, and this additional information could make our opinion change. Probabilities that are given with information are called conditional probabilities. So for example, let A and B be subsets of S. We can either think of these as discrete subsets or regions in the plane. And let's pick an element of S. The probability that this element is in A is either number of elements in A over number of elements in S. It's our discrete model. Or area of A over area of S. That's our continuous model. Now what if we find out that the element belongs to B? Then we can forget about everything outside of B and just focus our attention there. So our new probabilities are area of A intersect B over area of B. That's our discrete model. Or, number of elements in A intersect B over number of elements in B, or area of A intersect B over area of B. It's our continuous model. In general, we write P of A slash I, probability of A given information I, or sometimes the conditional probability of A given information I. And that's our opinion about A after we hear the information I. Now sometimes the information will change our opinion. That is, probability of A given I is not equal to probability of A. And sometimes it won't. Sometimes we'll have probability of A given I just equal to probability of A. So let's do one example of each. Let's let S be the numbers 1 through 12. Let's let A be the even numbers 1 through 12, the subset of even numbers. Let's let b be the multiples of 3 in 1 through 12. So 3, 6, 9, 12. And let's let c be the numbers 1 through 7. The probability of A, the probability of having an even number, given that we're in the set S, is there's 6 even numbers over a total of 12 numbers, so it's 1/2. Now the probability of A given B is, so if we know that we're getting one of the numbers 3, 6, 9, 12, then there's 2 even numbers there, 6 and 12, and a total of 4. So that's 1/2. So actually that's equal to the probability of A. Learning that the chosen number was a multiple of 3 did not change our opinion about whether the number was even or not. Alright, but let's use C. What's the probability of A given C? So if we know that we're in C, 1 through 7, then the even numbers in there are 2, 4, 6. There's 3 of them. And then the total number of numbers is 7. So 3/7. So that's not equal to 1/2. So it's not equal to the probability of A. So finding out that the number was between 1 and 7 did change our opinion about whether it was even. Finding out that the number was a multiple of 3 did not change our opinion about whether it was even. So probability of, in general, A given B is number of elements in A and B over number of elements in A, or the area of A intersect B over the area of B, or the probability of A and B over probability of B. So these first two formulas come right from the definition. And let's see why the probability ratio follows immediately from these. So the reason is so we have the probability of A given B here. The probability of AB over probability of B equals, let's see, probability of AB is either the number of elements in the intersection of A and B over number of elements in S over number of elements in B over number of elements in S, or it's the area of A intersect B over the area of S over the area of B divided by the area of S. So we can see that the 1 over cardinality of S here cancels, leaving us with cardinality of A intersect B over cardinality of B, which is exactly this expression for probability of A given B. And similarly, the area of S and area of S cancel, leaving us with area of A intersect B over area of B, which is exactly what we have there. Alright, now let's redo the previous example using the ratio of probabilities definition. So the P of AB over P of B formula for probability of A given B. we'll get the same answers. I just want you to see what the difference in computation is. So again, let's say S is the numbers 1 through 12. A is the even numbers. 2, 4, 6, 8, 10, 12. And B is the multiples of 3. 3, 6, 9, 12. And C is the numbers less than 7, less than or equal to 7, 1 through 7. The probability of A given B, we could write as probability of A and B over probability of B. So probability of A and B is, we've got two numbers that are both even and multiples of 3. The probability of getting those two numbers, if we're choosing a number at random from S, is 2/12. The probability B is 4/12. So we've got 2/4, which simplifies to 1/2. So we get the same answer we got before. The difference in our computations is that we have fraction over fraction. The denominators cancel, so it's the same expression as cardinality over cardinality. And then the probability of A given C is the probability of AC over probability of C. Now, probability of C is 7/12. Probability of AC is an even number which is less than or equal to 7. So there's 2, 4, and 6 in there. So 3 out of the 12 numbers are in A and in C. And then we cancel the 1 over 12 from numerator and denominator, and we get 3/7, the same number that we got before. So depending on how information is presented to us, it might be easiest to compute conditional probability of A given B either by taking number of elements over number of elements, or area over area, or probability over probability, and we'll get the same answer. All right, now let's look at another example. So let's say we'll use a book example that we talked about in discussion. Let's say 50% of readers like book A, 40% like book B, and 30% like both. The question is, what is the probability, or what fraction of readers? Now let's pick a reader at random and call it probability. So pick a reader at random. And if the reader does not like book A, what is the probability that he or she does not like book B? Alright, so this is different than just picking a reader at random and asking, does the reader not like book B? Because we already have the information that the reader does not like book A, and let's think about how we're going to use that. So one way to organize the information here is in a Venn diagram. So here's, let's say, all the readers who like book A, and here's all the readers who like book B. We know this is 0.5 total, this is 0.4 total, and there's 0.3 in their intersection, which tells us that there must be 0.2 in here that like book A but not B, and 0.1 that like book B but not book A. So together, the union has probability 0.6. So 60% of the readers like either book A or book B, or possibly both. Now what do we want? We want the probability that the reader does not like book B, probability of, let's say, B complement, given that the reader does not like book A complement. Alright, so this is the probability of A complement and B complement over the probability of B complement. And since we're not given actual numbers of readers, I think probabilities might be an easy way to look at this. Alright, so we said 0.4 is the proportion of the population that likes book B. So I guess it's 0.6 that doesn't. And then the probability that a reader likes neither book A nor book B means that they're not in the 0.6 here. So that means that there's 0.4 outside of this region. So we've got 0.4 over 0.6. Get rid of the decimal point, that's 4/6, and actually 2/3 is what it simplifies to. Now I suppose we could get some of these numbers here without using the Venn diagram, so let's try that and see how it works out. So we need two probabilities for this fraction. I guess probability of B complement is pretty easy because we know probability of B complement is 1 minus probability of B. So that's 1 minus probability of B is 0.4. So that's 0.6, which we got on the bottom here. Now how about the numerator? Probability of A complement, B complement. So the probability of A complement, B complement is, I'm going to write this with the intersection sign, even though we often don't. And I'm going to write with the bars instead of the C for complement. Now, A bar intersect B bar equals A union B, the whole thing bar. So remember, when we have intersections and unions, if we take the bar of a union, then that gives us the bar of the sets individually, and the union turns into an intersection. So we look at this and recognize that it's the bar of A union B. So that means it's the complement of A union B, so 1 minus probability of A union B. And the probability of A union B is probability of A plus probability of B minus probability of the intersection, which is, these numbers are all given to us. 0.5 plus 0.4 minus 0.3. So 0.9 minus 0.3 is 0.6. Alright, so if probability of A union B is 0.6, then 1 minus the probability of A union B is 1 minus 0.6, which is 0.4. and 1 minus probability of A union B. The reason we want this is because that is probability of A complement B complement. So using this formula, probability of B complement given A complement is probability of A complement B complement over probability of B complement gives us 0.4 over 0.6, which is the same thing that we got last time, more commonly known as 2/3. The end.